Welcome to purchase our instrument. First of all, this is the light guide arm. This is a horn probe, and these three are the cutting probes that will be used when cutting patterns. These are our private parts. There's a foot control switch, a funnel for water. First of all, you need to prepare a piece of ace paper. There is also a thermal paper that we usually use when we are at the cashier. Another 5 liters of purified or distilled water is required. Let us understand the installation of the light guide arm. First of all, we need to close the light guide and push it vertically down through this hole here. We have a line here and we stick it in the corresponding hole. Attach this clear pipe too. Next, let's install the foot control switch of the machine. After the machine is installed, we need to add water to the machine. We found these 3 holes on the back of the machine. The first one is the water filling hole, the middle one is the overflow hole, and the bottom one is the water outlet. It can only be added with pure or distilled water. Until this spillway has a continuous flow of water, that means it's full. Fill up the water before you can use the machine. The water in our machine is required to be replaced once a month, regardless of whether it is used or not. After the machine is assembled and installed and the water is added, we can turn on the power to start the machine. Power it on and turn it on. Now go to our home page. First of all, we have 3 options on it and we'll choose the first one. A laser can do that, and then we have 4 modes. First of all, the first one has a picture of a woman, skin or acne pits or stretch marks and scars and so on. We can choose this one. And then 3D, this is about making some cuts and making some bumps. Or some senile papilloma or some flashy cut with some raised dirt, and we can choose the 3D model. 3D is mainly done to tighten the vagina. The last one to do the vulva pink or the size of the labia closed, we can choose this pattern. Let's first take a look at the first skin beauty mode, which needs to be matched with this trumpet-shaped probe. Install it on the light guide arm. And then what we are going to have here is we are going to have a blowing pipe, and then we are going to have a screw here. We just attach it to this little screw, and as we operate it will have this cold air to cool the skin of the customer. Okay, let's look at the interface again. First of all, the interface. The icon at the top here is the preview. The shape that we have here is going to show up in our infrared right here, and we are going to click on it. The shape of the infrared ray in this place is going to be the same as the shape that you set up, including the size, and it's going to represent that we are going to output in this place in a minute. And the shape of the final point is the shape that we see in the infrared right now. So before you do that, you have to preview it and click on it so that you can see the shape. If you don't have a point, it's a single point. This is no way to judge the part that we are going to operate later on. The next key is the keep key, which is our save key, and all the parameters in here we can set it in advance, and after setting it, you click save. Then the next time we come in, all the parameters will be the same as the last time you saved them, and that will save us a lot of time. And this key is the back key, and we click it and we go back to the home page, and this is the edit key, and we can leave it alone and it doesn't do much good. But what about when we need to switch this shape? All we have to do is click on this 2.2 shape and click on it, and now we're in a circle, and we're previewing it here, and we'll see that it's a circle shape. And then there's a square, triangle, diamond, so we can go with this one that we're working with. What kind of part does it need? What kind of shape or what kind of area can we adjust? So once the shape is set, let's make a square, and once the shape is set, let's say we are going to make a long scar, so we can move this up and down and left and right and this arrow. And if we adjust it a little bit and it changes its shape a little bit, like if we hold down this down arrow and we don't let go, we can see that the height of the shape is going to compress a little bit. We're in the preview here, and you can see that it's going to be the shape that we adjusted in the middle. You can see that, so let's say you want to make this width a little bit smaller, and we can click on the arrow on the left and not let go, and that changes the width of this arrow, and now I've made it a little square. Well, it's as small as 4×4 and as large as 20×20, and we can see that at its maximum. So here are some of the energy parameters that we need to adjust, and this is the point energy. And the edge is going to be the height and the width, and all the shapes are going to be the maximum 20×20. So this point energy represents an intensity of the energy of the point that we output, and this is a coverage that is calculated by this is your shape and size, and this is a coverage by the spacing of the points, and these two parameters are automatically converted without adjustment. We just need to know what it means to look at it. Here is the intensity of a power. What's the intensity of a power? He's from 1到60. Wow, that's all. And when we operate it, we need the machine, and there's always a piece of black paper next to it. We need to test what the energy output is on the sheet and what we would normally do if we did a normal peel. If we improve the skin, we can penetrate half of a sheet to one sheet. If we're working on a pore problem, we can penetrate one sheet to 1.5 sheets. If we're working on this particularly bad pothole or acne, we can penetrate 2.5 sheets. There are some scar stretch marks. We can, according to its severity, the degree of depression, can penetrate a half to 2.5 sheets of paper. So much we can choose its energy according to a customer's situation. Choose his power, so all the power adjustment is to see how deep he penetrates the paper. So in this place, we cannot prepare parameters and choose according to a result that he produced on the paper. Okay, so this place represents the amount of time that the point stays, and the longer it stays, the greater the overall thermal damage. So the more time this laser dot has to penetrate under the web and under the skin, the shorter your stay, the shorter the penetration time he gives him. So what we do here is we normally adjust it to 0. So let's say you want to penetrate deep, but you've already turned up the power and he can't penetrate, so we can go to 1, 2 or 1, 5. But by default, the first choice is to go to E and Ling is fine, and here is the time between the point and the point is the default is millisecond and don't touch it. And then what this represents is the point distance, which is the distance between a point, and what we usually use is about 0.712, and it is also selected according to the size of an area of the operating site. If we're working on a small area, we can put this point in there a little bit and make it a little bit smaller to 0.8, 0.9. So if you're doing something really big like a stretch mark all over your stomach, then we can go to a point spacing of 0.212. And here's a pattern of scanning that's divided into out of order, and then there's an order. So now what we have here is a criterion, which is the order in which we go down the middle of the point that this place represents. He's going to go from the two sides to the middle, and then it's going to be a random order, and then it's going to be random, but these three patterns it's just that the way you print it out is different, and you end up taking this shape and putting it together in the shape that you set. So this is a place where we can usually choose the order, or the order is out of order is okay. Here can represent the number of scans, so we generally default to 1. Okay, so what we are going to do now is we are going to run a test on this energy, and we are going to have an A in front of our machine, which means we fold it in half, and then we fold it in half, and then we fold it in half again. It takes 3 folds in half to do it, After that we're at SHAR1S, but we don't know how much he can penetrate or if he's working on a project with us, so let's test it on paper first. Our shapes, and then we are going to hit both, and we are going to hit E, Ling, and then we are going to hit preview here, and we are going to see the shapes, and then we are going to hit this prep button. When we are ready, we can pull the light guide arm down on our paper. The feet must fit completely under the flashlight, and then place the foot on the middle layer of the foot switch. If you push it down and you don't let go, you'll see random drops, and when you're done, he stops. We're loosening our feet. And then you can see on the manipulation side or on the paper, we can see these little black dots. So the first one penetrates the second one completely, and there's a black spot on the back, and then there's a black spot on the third one, and there's just a little bit on the top, and that's called penetrating too, and it penetrates both completely, and that energy is SHAR1S. So if you think it's not suitable for you to operate the project, and you think the energy is a little strong, and you just want to penetrate 1.5, then SHAR1S of energy is a little too strong. So let's lower the energy again. Let's say I'm down to 9 nits, and then test it on paper. Let's see how much it penetrates. So that's how our energy is adjusted, and let's see how it penetrates. One goes all the way through, and then the second one has dots on it, and then the second one has no color on the back at all, and that's called 1.5. So let's see, I'm going to manipulate 1.5 at a depth. So 9 watts is a good fit, so we're gonna test it on paper. So what do we do now, and what do we do when we test the same power at this point, and we turn it up to 0.8, and we do it again, and we see. So at this point we are going to turn the density up to 0.8 and 0.8 in a row. It's also going to be a little bit denser down here, and that's a difference between the dots. And the depth it also penetrates 2.5 times because our power doesn't change and our residence time doesn't change, so it's this one that's brought by the density aspect. In terms of parameters, there is a difference in the result after the operation. That is, after all your parameters are adjusted and confirmed, after all aspects including the shape are confirmed, we can directly align the part to be operated. Push it down, don't hang in the air, make sure it's so close to the skin, and then when you push it down it's going to hit the skin, and then when we are done with this place it's going to have little white spots coming out. And then you move on to the next place, and then you move on to the next place, and then you move on to the next place, and then you move on to the next place, and try not to overlap. So let's talk a little bit about our sanity model, and it's focused on these bumps. For example, when meat comes in or when you comes in, there are 3 modes. The first one is called the single point mode, and it just goes to the next point and then it ends. So in general, this mode is used less. And then the second one is cutting, and it's a continuous pattern and there's always energy output, and this one in general is targeted at some hospitals where they do this, and they do this meat specifically. It's a cut in case of a foreign object and it's not normally used, and what we usually use is a pulse pattern. We can adjust to the parameters we want and then go to 11 o'clock for this bump and smooth it to make a mold area. And then on the energy side we can do a test on the paper where we see this color on the paper, but we haven't pierced a piece of paper, and we can test it later on at about 21S. Well, this place down here is the one that's the name of its pattern. Pulse pattern, and then this place where it doesn't need to be adjusted here is a pulse width. The greater the number, the greater the overall energy is the heat damage, so we default to 0. When you need to adjust the energy and you just add it here. And then this is the time between the pulses, and we have to adjust this parameter, and if you don't adjust it, it's a cut. We need to adjust this pulse interval, which is the light rest time between 100 and 150, and if you adjust it to 100, it will go down very quickly. If you set it to 150, it's going to go down a little bit and it's going to slow down a lot. What about our mode? It's going to use this probe, which is our pulse probe. Pinch the bottom part and then turn the silver part on top. After this probe is removed, we will put this probe on it. It's the same when it's installed, and we have another tube here and we need to connect this tube to it here. This is also blowing for soothing skin. In that case, we've installed the lock handle and it's just hanging like that, so we don't have to worry about it. Okay, so what we're going to do now is we're going to set up this parameter and then we're going to test it on paper. Do a test before the operation. We are ready to prepare. After we step on the middle layer of the foot switch, step on do not release that step on. At the same time, we need to move this probe. You can see that there are a lot of little black dots on it, and you can hear a rattling sound, which means we're on the right pattern. And then we take a look at it on this one, whether it penetrates a piece of paper. We can see that there is no point on the back, which means that our energy including our pulse interval is okay. We can use this parameter to give the customer operation, but when it is operated, let's say you're trying to manipulate a bump U, and we can directly target that U by drawing little circles like this and hitting it like this. And then we can continue on this, and the way that you draw little circles doesn't sit in one place, it has to look like this. So let's talk about 4D. 4D, he needs to use this private piece of the lens. We need to manipulate the vagina first. So do this internal factor compress, so this is the preview and then this is the return key. This is edit or you don't have to touch it, and this is the prepare button, and this place in the middle is a circle by default. The shape and size do not need to be adjusted. Here is an energy output. We need to do the test on this thermal paper, so if you want to do a private project, we need to prepare a thermal paper. Well, here's one of his stays. So here's a number of points, that's a dot under a dot, that's a circle over a line, and for slightly younger customers it's 24 points, and then it's between 24 and 48. Older people are particularly slack. We can go down and adjust 32. 36 can adjust, the maximum can be adjusted to 48, but in general, try not to exceed 48. Is this 24 is usually more. This is the distance between the dots and the line, and this is the size that he's going to hit because we do the volver. The probe has this scale on it, and we need to draw out slowly in the process of operation. Then we generally draw 0.5 centimeters per shot is a distance of 5 millimeters. So this place we choose 5 millimeters on it, and we don't play a shot, and we draw 5 millimeters. So this 5 right here is the pattern of scanning, and it's out of order and it's in the middle, and we usually just pick the order and that's it, and then this is the number of scans, and we just do it once by default. What this represents is the function of the scan, and what you would normally set up here is, well, if you move the size of the cone by 5 and the height is 5, then we can adjust it to 5. It's 5 lines, and if you want it to be more dense, then we can change the number to 7 and the default is 5. When we do the test on the paper, this thermal paper, the paper does not penetrate. You can see the black spots on the surface. So we can start with a low energy, something like 7 watts, and we first need to install this probe that we have. The private probe, the first step is to take the original horn head and remove it and find our private lens. Then find this probe and put it on. We'll restore this to him and put it on. Once it's installed, this probe down here will see the infrared dots. The infrared must fall on the spire at this point. So if you don't fall, we can move it up and down and right around the circle, all the way to the point where he lands on the top of the spire, and from any angle he lands on the top of the spire, and that's it. And then we wrap it in thermal paper. Wrap it around to simulate the environment of the inner vagina. Then step on it and you can see it going round and round. And then we expand it out, and there's a parallel where we can see that the dots around here represent us. The 24 points that you set up, there are 24 points in a row, and what about this place? There are 5 points in a row and 5 points in a column. That means you set it up here. But this height is the height of the 5 millimeters we have here, so if you want to make it a little bit denser, we'll just turn this number up. If you want more lines, we adjust it like this, and what we do is we put this place in the inner vagina, and we use this as a standard to look at the scale. This place is pointing, and when you hit it, you take 0.5. When you hit it, you take 0.5. All the way to this vaginal opening here, so that we can finish the cycle 3 times, and then we are going to do one of the external sounds, and we are going to tap in, and we are going to have a little square here. That is, the default is that you cannot move under the square, and we will also do the test on the paper for a while, that is, do not penetrate the thermal paper. And then hit the client's skin, and you can see that there are small white dots, which means that this energy is okay. And then this place is going to have its dwell time, which we default to E, and then a point interval is going to default to E millisecond. This is what the spacing of the dots means, and we usually default to 0, 1 millimeters, and we don't have to move it, but if you think the bottom dot is too dense, you can turn this place up a little bit, and when he goes down he's going to suck a little bit, and the default is 0. When then what you have here is a scan mode out of order and out of order, and in general we can use either out of order or out of order. This place represents the number of scans and the default is 1, so what do we do now? It is necessary to install this private lens first, which is a lens specially used for both the inner and vulva. And then I'm gonna find this probe, I'm gonna mount it from here, and when I mount it we're gonna click on this preview right here. I can see this square, and I can click on it to prepare. How to prepare us in the process of operation? Is it not attached to the customer's skin? Is it about 1 or 2 centimeters away? On the other hand, it does not penetrate a piece of paper, and if you can make small white dots on the client's skin, it means that the energy is okay. So it went back and forth as we went along. It can be overlapped by 1/3 so as to sweep the whole of the customer. Let's talk about the maintenance of this machine. The first step is the maintenance of the lenses. It needs to be wiped clean after each operation with the alcohol pad or cotton swab. All of these chips have to be wiped with alcohol, and then this private accessory needs to be sterilized and sterilized with that high temperature sterilized pressure cooker before it can be used. Then we can use alcohol to disinfect the other accessories. All the maintenance of these surfaces of the machine, including our handle, can be wiped clean with alcohol. And then the water in our machine, which is required to be changed once a month, must use either distilled water or pure water. If the instrument needs to be transported, the water must be discharged before transportation, and the water must be filled before the machine can be turned on. In the process of transportation, after our light guide coil is removed, the dust cover must be covered to prevent dust. When we replace the lens, we must pay attention to only the corresponding probe can be installed in it. And then everything in here is not to be touched. When we replace the parts, do not disassemble other parts.